Good morning everyone. Here we are with our lesson number 4. We start now the exercise 3. Remember, we're still following your book. Okay, so what we have done for now, it's a big table representing the 7 graphs that you have to know, the 7 different functions: parabola, straight line, hyperbola, etc, etc. So now that we have the basic for each graphs, we're going to enter in detail in the different graphs. So we start with the easy one, straight line. In this exercise, there is nothing new, only thing that you already saw and that we already worked together, but just to review it. Alright, so first thing, for straight lines, the equation is always y equals mx plus c, with m being the gradient and c the y-intercept, so the point where the line crosses the y-axis. Alright, you know that if the gradient m is positive, then the line is inclining, and if the gradient m is negative, then the line is declining. Alright, so that's the basics. Then, here, second application. So first thing that you have to notice here, a horizontal line has an equation as y equals c. So if the y value is equal to a constant, then you have a horizontal line. Obviously, if you look, if the y value is equal to 3, as y equals 3, then that means that for any x value, you always have a y equals 3. So you create an horizontal line. For this specific line, the gradient is 0. So from this equation, y equals 0x plus c, y equals 3. And you have an horizontal line here. You can have y equals minus 2, that you create an horizontal line at minus 2, y equals minus 4, etc, etc. So if y equals a constant, you have an horizontal line, constant y value. Alright, same thing but on the other axis. On the x-axis, you can create a vertical line. So, if the equation is x equals c, then you create a vertical line. For instance, if x equals 3, for any, doesn't matter what y value, but x is always equal to 3, so you create a vertical line at 3. You can get x equals minus 2, a vertical line in the negative x's, or x equals minus 4. Any value is possible. So, if x equals a constant, you create a vertical line on that specific x point. Alright, in this case, the gradient is infinite. The line is growing at an infinite rate directly straight up. Alright, next page. How to know if two lines are parallel? I hope you remember that. If the gradients are equal, so if the two gradients are the same, therefore the two lines are parallel. They're growing on the same rate. The inclination is equal. So they are parallel. Right, so for instance here, the two lines y equals 2x plus 4 and y equals 2x minus 2, they both have a gradient of 2. So if the two gradients are equal to 2, they are equal. Therefore the two lines are parallel. Doesn't matter what number is the gradient, if that's the same one, they are parallel. Alright, now for the perpendicular line. Next point. Two lines are perpendicular if the gradient of the first one times the gradient of the second one equals minus 1. That means the two gradients are opposite. And if the two gradients are opposite, one goes up, the other one goes down, and they intersect as a 90-degree angle. So, if they ask you are y1 and y2 perpendicular, then you take the gradient of each. So for instance, in this example, first one, y equals 2x plus 4. Second one, y equals minus a half of x plus 2. So gradient 1 is 2, gradient 2 is minus a half. So now I just need to apply that formula. m1 times m2 equal what? So 2 times minus a half, that gives me minus 1. Conclusion, the two lines are perpendicular. If you get minus 0,9, it's not perpendicular, it's not equal to minus 1. It must be exactly minus 1. If yes, the two lines are perpendicular. They intersect as a 90-degree angle. Alright, so for the exercise 3, that's all. Nothing new. Basic things about straight lines. But you must be able to build and sketch those straight lines. And here, for this specific exercise, they gave you restrictions almost for each question. So, let me explain to you how it works. And I'm going to use the example 1 here that I redrew on the board there. So the question would have been, sketch the graph of y equals minus x when x is greater than minus 3. So here you have a restriction. You just want x to be superior to minus 3. No value of x smaller than minus 3. So, how does this work? Obviously, first you draw your two axes, x and y. Then, you focus first on the equation of the line. And you use the table method. You draw your table, you choose few different x's, calculate the different y's, and then you plot. But here, the only thing you have to check is where is x bigger than minus 3. So that's why this blue line, which is the straight line y equals minus x, this is why this blue line does not have arrow pointing on both sides, because it cannot be smaller than minus 3. So for x, you see minus 3 of x is here, so you don't draw anything smaller, you're only going to draw the greater than part. So that's why you start your line at minus 3 and you carry on in the superior axis on the right hand side. Alright, remember that sign means strictly superior to. It's not including, it's excluding the minus 3. This is why you must draw a white circle on the minus 3 value. On the right hand side, you don't have restriction on the bigger axis, so you draw an arrow pointing towards infinity. That's for example 1. Alright, with the example 2. Here they ask you to sketch 4y minus 8x equals minus 8. And they force you to draw only x into the interval minus 1 included up to 3 excluded. Alright, so first, can you draw 4y minus 8x equals minus 8? It doesn't look like any equation that we used. So, you see that the x has a multiplication only. There is no square, there is no exponent, nothing like that. So you know it's going to be a straight line, but you need to rewrite this equation, keeping the y alone on the left and everything on the right. Did you notice all the equations so far was y equals 2? So you need to have only y on one side and the rest is your equation on the other side. So that's why you have to move the thing around the equal sign here. So first step, you must write it as y equals mx plus c. So you go from 4y minus 8x equals minus 8, and you move first the minus 8x from left to right, becomes positive 8x on the right. Then that 4 that's with your y on the left must be taken on the other side, and to do so you divide by 4 everywhere. So that's why you get now a y equals 8 divided by 4, 2x minus 8 divided by 4 minus 2. And here you have this equation as a normal y equals mx plus c. That's exactly the same than the first one, but that's the way you want it, because now you know which one is the gradient and which one is the y-intercept. That's a lot easier to treat this type of equation. Alright, so now that you've got that, and this is why I wrote y equals 2x minus 2 here, because you're going to use the easy one. Right, and you want to sketch it for x from -1 to 3. So same thing, you use your table method, you choose 2 or 3 or 5 value of x, and you calculate the corresponding y's for this function. Once you've got it, you draw your line, and you need to think, where do you stop? So on the left hand side, you stop at -1 included. So on the -1 of x, you stop here, but you include this point with a dot, a full dot. So that's why you've got a full dot on the left. And on the other extremity of your interval, you stop at 3. But soft bracket indicate that you exclude this 3. So on the 3 value for x, you're gonna stop your graph and use a white circle to represent that you exclude 3. So this line is the function, the graph for y equals 2x minus 2 for the interval from -1 included up to 3 excluded. Here is what you have to do now, and that's your homework for tomorrow morning at 10 o'clock, please. So you have to use your impact book. In case you don't have your book, please ask us. We'll send you a picture of the work. But that's easy. That's the exercise 3 for the unit 11, and you do all the questions. That's really simple, please. So that's questions 3.1 to 3.5. 5 questions where you have to do this. Draw your line and be careful with where you stop your line. All right. Enjoy. Bye-bye.